In this lesson, we're going to be talking about something called tangent lines. So a tangent line is a line that intersects the circle at exactly one point. The point where it touches is called the point of tangency. And a tangent line to a circle, it's tangent if it's perpendicular to the radius at the point of tangency. So if this is perpendicular to this, we consider this a tangent line. Another way we can see a tangent line is if it goes all the way past that. So it's going to touch exactly one spot and then just graze the circle, but it's going to be perpendicular to the radius at that point. So for these, determine whether the segment is tangent. Well, if it's tangent, then this is perpendicular, which means this must be a right triangle. So we know that if 20 squared plus 21 squared equals 28 squared, that we have a right triangle. So if I do this, I'm going to put a question mark here because I'm not actually sure if that's true. But when I plug that in, we get 841 on this side and 784 on this side. If that is not true, then that is not a right angle, so this is not a tangent. Okay, you try the next one. So here, if this is a tangent line, then this is our right angle, which means that 14 squared plus 48 squared needs to equal 50 squared, which in fact it does, so this is a tangent line. All right, in our next problem, find x. Assume that the lines that appear tangent to the circle are tangent to the circle. So if this is tangent, that means this is a right angle. So a squared plus b squared equals c squared. So 8 squared plus x squared equals this squared. Well, this 9 is just part of the line. If this is 8, then this is 8. So the hypotenuse of this is going to be 17. So if we solve for x here, we get 15. Okay, we'll try the next one. Okay, just like that, this is 15. So this one's a little bit trickier. Okay, so 36 squared plus 15 squared equals the hypotenuse squared, which is going to be x plus 15 squared. I get this number is 1,521. Then I'm going to take the square root of both sides, which gives me 39, and then subtract 15. So this is 24. Okay, our next concept, if two segments from the same exterior point are tangent to the circle, then they are congruent. Okay, so we have an exterior point and this tangent, exterior point and this tangent. So that means x plus 3 equals 7. So x is equal to 4. So you can go ahead and try the next one. So again, if they're coming from the same point, these two are equal, set them equal, solve for x to get 2. Okay, in this picture, we have a polygon that is circumscribed around a circle. So we have the circle is inscribed, the polygon is circumscribed. Well, if that's the case, these lines touch at one point, which means those are all tangent lines. So the segments that are tangent are all of them. AF, AB, BC, CD, DE, and EF are all tangent lines to these. So we can combine those two ideas. We have ABC is circumscribed around circle O, which means these are all tangent lines, and they're coming from a single point. So this distance and this distance are the same. So if this is 6, this is 6. This distance and this distance are the same. So if this is 12, this is 12. And this distance and this distance are the same. So if this is 8, this is 8. So if I add up all of those values, we get a perimeter of 52. Okay, let's do another one. First it says find x, then find the perimeter. Well, if this is 2, this is 2. If this is 6, this is 6. So x is going to equal 8. If this is 3, this is 3. If this little thing is 1, this little thing is 1. If we add all those up together, we get 24. So your turn to try the last one. So in this picture, first to find x, these two are the same. So x equals 6 after we solve that equation. If this is 5, this is 5. If this is 9, this is 9. If this is 4, this is 4. Add all those up to get 52. And that is tangent lines.